Okay, so we look at this one and it doesn't look anything like the other ones we've seen. Okay, so what to do? These next few are a little bit different. And then you just get excited, like, cool, what's something I understood all of those others. Now let's really challenge ourselves. So sine theta equals 3 cos theta. Now, we could picture this again if we wanted to of, well, sine theta looks like that, cos theta looks like that, so 3 cos theta is stretched, so when are those two graphs equal to each other? Well, it looks like over there, and of course, the graphs would continue, and my drawing got a little bit atrocious, so I'm just going to hastily move all of that away. Fortunately, we don't need to draw them, because we can solve these by using a nifty little trick in some ways. Now, sine theta, cos theta. Here's my hint. Tan theta equals sine theta over cos theta. And that works always as long as, of course, there were asymptotes at theta equals 90 degrees. So as long as theta is 90 degrees, we can happily do this. Well, sine of 90 doesn't equal 3 cos 90. Thank goodness. So because that's not a solution, we can divide through on our equation and divide both sides by cos theta. Okay, well, if we do that, the left-hand side is just tan theta, because tan theta over cos theta is tan theta. And the right-hand side, well, those kind of cancel each other out quite nicely. So goodbye to you, and hello to just the number 3. Now, tan theta equals 3. As it happens, I think we did a similar example before. So we can just solve for this and go, well, our reference angle is just arctan or shift tan of 3. Pull out the calculator, and the calculator is somewhere over there. Calculator?
Calculator, are you over there? Calculator.
I don't know. Hopefully it's okay. Well, I don't know what happened there. But tan, so shift tan of 3, close bracket, 71,56. A no decimal places type of person for these at the moment. So no decimal places, 72. Tan theta is positive. So our cast diagram tells us which quadrants we're in, except we don't need our cast diagram. Because if tan 72, then we've got 72, or we've got 180 degrees plus 72. But the tan graph repeats itself every 180. So it's not that we're working in 2 quadrants so much as theta equals 72 degrees, but we can keep adding 180 degrees, and we'll get to the next one, and we'll get to the next one, and the next one, and we could subtract. So there it is. Actually quite short and sweet looking at it that way. Okay, so let's head into the next one. And this one says, tan theta times, remember this little dot means times, and it could be at the bottom or something. Tan theta times sine theta equals tan theta. Cool. So based on the previous question, it would seem quite reasonable to go, let's just simplify this. Tan theta divide tan theta. So we've just got sine theta equals 1. Except, what happens if theta is 0? Well, if theta is 0, it looks like our solution would work, right? Because tan of 0 is 0. So 0 times anything, well, sine theta, remember, also is 0. So 0 times 0 equals 0. So that should have been a solution. But if we divided through by tan theta, we would have lost that solution. So we cannot just divide everything by tan theta. Instead, let's rearrange or manipulate such that we have everything that looks interesting on one side equal to 0. Now, something just jumps out for you to do, and I think we did these in some of our questions previously, and that is there's a common factor here of tan theta. So if we take it out, we're left with tan theta times sine theta minus 1 equals 0. And now we can clearly see these solutions because either tan theta is 0, because 0 times anything is 0, or the brackets are 0. So, or sine theta equals 1, or sine theta minus 1 equals 0. So sine theta equals 1. So we've got two different solutions now. So if tan theta equals 0, theta could be 0. No need to do any shift tan nonsense here. Just go back and think your graph looks like that. There's your answer. And the tan graph repeats itself every 180 degrees. For sine theta equals 1, again, no shift sign stuff. Just think, what does your sine graph look like? Well, sine theta is 1 over there at 90 degrees. And the next time it's going to be 1 is 360 degrees later. So theta equals 90 degrees, and that's going to repeat every 360. Okay, so two slightly different things. One, we rearranged and factorized. And two, our solutions weren't kind of a reference angle and on the Cartesian plane because they were such special answers. We went back to the graphs. Okay, on a roll, I think let's stick with it and go. And
for this one, we're going what's going on.
Oh, well, I don't know. So we've got cos squared theta minus 3 sine theta minus 3 equals 0. We can't do any of the tricks we used before. It's not like there's a common factor we can pull out, and it's not like we can divide through by, say, sine theta to get, or divide by cos theta to get a tan theta or something like that. So here's our little trick for this one. If you remember, sine squared theta plus cos squared theta equals 1. So we could change this cos squared theta, because cos squared theta is 1 minus sine squared theta, right, from that identity. Now, as I'm writing this, and you're diligently copying it down, I'm sure the big question is, but how do you know to do this, right? Because once you see it, you can go, okay, well, that's all well and good, but how in the world do you know that this is a good method to go? So the reason that I've chosen to do this is then our trig functions, we just have signs everywhere. Sine squared, sine, and a constant. We don't have a mixture of sine and cos. So even if we look back at our first example, we made sure that we didn't have a mixture of sine and cos, so we manipulated so that we just had tan theta. In our second example, we didn't ever look at tan and sine at the same time. What we did was that we rearranged and did some magic so we could just look at tan theta and get a solution, or we could just look at sine theta. So with that concept in mind, what we're doing here is saying we don't want coses and sines. So let's use our identity, our squares identity, so that cos squared kind of turns into sine squared, so that our equation now is minus sine squared theta minus 3 sine theta, 1 minus 3, I think, is minus 2. And if I multiply this by negative 1, maybe you can see it, but also maybe not. Okay, I want to factorize the left-hand side here. So if we've got this is the important bit. Sine squared theta plus 3 sine theta plus 2. Compare that with, say, x squared plus 3x plus 2 equals 0. Well, that's easy. You've done those, quite a lot of those. You go bracket, 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 bracket. I know how to factorize a trinomial. There isn't really too much to do here. Plus 2 plus 1, x equals minus 2, or x equals minus 1, and we're done. Same idea here. Instead of x squared, we've got sine squared. So in this case, we're also going to go bracket, 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 bracket equals 0. Either that bracket 0 or the second bracket 0. Well, sine theta times sine theta is sine squared theta, and 2 times 1 gives us 2. So we have two solutions. Sine theta, let me show that step, plus 2 is 0, or sine theta plus 1 is 0. In other words, sine theta is negative 2, or sine theta is negative 1. Pretty nifty, eh? But as I said, the trick, of course, is knowing when and how to do that. Well, the when to do it is that we've just got one trig ratio we're dealing with. And we could factorize it because it's a trinomial. Okay, so then we need to solve each of these. Now, for our left option, well, let's see. Sine theta goes like that. It goes up to 1 and down to minus 1. So I don't believe we're going to have any solution over here. Now, in the second case, sine theta looks like, well, sort of like that, but not really at all. Like that, goes to minus 1 and 1. At minus 1, we know that that value there is 270 degrees. We know that the next time it's going to be negative 1 is 360 degrees later, or 360 degrees before that, if the graph continued. So theta equals 270 degrees, and that repeats every 360 degrees, where k is an integer. Okay, quite a lot, I know, but kind of, as I say, things are, hopefully they start talking to each other and you get a sense of this and go, oh yeah, the graph, they're repeating. Okay, well, I think that we're on to our last example. Now for our last example, we've got sine and cos, and we're going to use the same idea that we used before. But I think we'll do that in the next video.